Hi everybody, and welcome back to Foundations of Human Systems Engineering, HSE 542, and today we'll be talking about usability evaluation. So people often think about usability evaluation only as usability testing, but there's an awful lot of ways to evaluate a user interface or the usability of a user interface. They can really be broken up into kind of two categories. One can be thought of sort of analytic, and you can see that over here. And for it to be analytic simply means that you are evaluating or inspecting something, but you're not using users in order to do that. In fact, you as a designer or as a human factors engineer are doing this yourself. So an example of that is usability inspection. Usability inspection has a number of methods, although there's kind of two cornerstones to them. One is called the cognitive walkthrough, and the other is called the heuristic evaluation. In the past, people have kind of referred to these kinds of analytic methods as discount usability methods. And they're discount usability methods for a couple reasons. One is that they tend to be faster and cheaper for people to do. So often it turns out that usability testing, when we get real honest to goodness users in to do real honest to goodness tasks with a prototype, that can be expensive. Often you pay the users, it takes a while to recruit just the right users, it takes a lot of time to run them through the usability test and then to evaluate the data, or to analyze the data, I should say, and write up a report. So usability testing can sometimes be a bit time consuming and as a result expensive. On the other hand, usability inspection methods, these ones over here, tend to be faster and cheaper, probably not as good over the long haul, but certainly useful, and useful as a precursor to doing real honest to goodness usability testing. That is, when you have these expensive users in and they're using all your time to run research participants and all of those kinds of things, you don't want to be discovering kind of obvious usability problems, ones that you could have found just by going through and doing kind of an editing or an inspection of them. You want to do that with these things over here. So the way these things over here work, and I'll get into detail about them in a minute, is that evaluators review a user interface to identify problems. They usually don't complete tasks during this inspection, but the idea is to go through and kind of inspect the user interface in much the way you would inspect software code. That is, software code, often you're looking for, well, does it communicate effectively? If the programmer was to leave the company and somebody else had to pick it up, is it documented correctly? All of those kinds of things. Well, that's kind of what's going on over here, just with the user interface. Now the other one, and the more involved one, is what we often call empirical methods. Empirical meaning actually uses real honest to goodness data in order to evaluate a system, and that data requires users to provide those data. So the example of that is usability testing. So usability testing involves real honest to goodness users conducting real honest to goodness tasks with a real prototype or a real product to evaluate. And along the way, we keep track of human system performance measures. That is, if somebody's conducting a task, we keep track of whether they were successful or not. We keep track of their time on task, how long it took them to conduct the task. We might keep track of things like maybe we have a path that we expect them to take, that we intended for them to take, but they end up taking a different path in order to get to the same outcome. Well, that difference between those two, maybe they ended up taking a less ideal path, a more circuitous route. Well, the number of clicks that they take versus the number of clicks that they would have had to take, the way you planned on it, can be thought of as a deviation. Sometimes we call it a deviation from the happy path. So the happy path is what you defined as the ideal way you would like them to proceed. They actually did it a different way. What's that deviation? How many extra clicks did they have to choose? There's other things what we might keep track of too that aren't human system performance measures, but are more related to satisfaction and preference. So those are more verbal report measures. Those will be questionnaires and things like that. Also during usability testing, we will sometimes interview the users. We'll sometimes ask them to think out loud, all of those kinds of things, which are less quantitative, but also sometimes pretty important and useful. So I'm going to talk about usability testing in the next video, but for now, let's stay focused on this usability inspection methods. So let me go to the next slide here. Let's talk about the first one, which is called heuristic evaluation. So in a heuristic evaluation, one or more reviewers inspect the user interface. And as they do this, they have a list of best practices or heuristics. A heuristic is really a rule of thumb. It's kind of a rule that works most of the time. In fact, the vast majority of the time. Every once in a while it doesn't work, but it tends to be a pretty good rule to follow. It's not guaranteed to work every time, but generally it's well accepted practice. So they have this list of heuristics, and with those right next to them, these evaluators go through and they click through every component of a user interface, and they evaluate each component, say each screen, against those heuristics. So ideally, it's usually 4 to 6 evaluators will evaluate a product, and then a lead researcher will get that group of people together to discuss the issues, to reach consensus, and then to write a short report. Since the evaluators have a list of heuristics with them in front of them, basically a checklist of heuristics, they don't have to meet, or they don't have to be actual human factors experts. Instead, they're kind of supported by that document. So let's see if we can learn a little bit more about this. This is something provided on the web that you can take a look at, but there have been several sort of collections of heuristics that have been developed over time. The initial set was, I believe, 12 different ones. This is the second set of Nielsen's. For example, a useful user interface or a usable user interface will keep the system status constantly visible. There will be a match between the system and the real world. The user will have control and freedom. It'll be consistent and adhere to standards. It'll reduce the likelihood of errors by the person, the operator using it. It'll rely on recognition rather than recall memory. We'll discuss these things here in a minute. It provides flexibility and efficiency of use, aesthetic and minimalist design. It provides it helps users recognize, diagnose, and recover from errors, and also provides help in documentation. As I mentioned, there's a number of these various collections of heuristics out there. Here's another one that's provided by User Focus. This is a bit more focused on web usability, and it's important to recognize that user experience and usability are not just focused on the web. There's a huge number of products out there that aren't web-based at all. This is a little bit more focused on the web, but it still has probably some pretty good value for other things. As they point out here, this is pretty useful. This is kind of helpful for evaluating existing interfaces. That is, sometimes you really need to have something available to evaluate before you can use this method. There's limitations to it. It can reveal lots of issues, but in order to kind of identify the most important problems, that's still going to require usability testing, which we'll talk about soon. Although one expert can find a lot of problems, it's really better if you have multiple people, and it doesn't have to be an expert, although I should say one evaluator can find lots of problems. It's better if you have more than one evaluator. As I mentioned, often we'll use 4 to 6. So that's a good start in talking about heuristics. So as I said, there's a lot of different kinds of heuristics out there. It started out with Rolf Maulik and Jakob Nielsen developing this set in 1990. that talked about using a simple and natural dialogue, speaking the user's language, that is, not using a lot of terminology that the user is not familiar with, etc., not being too techy in your descriptions, minimizing user memory load. So for example, providing things like recognition as opposed to recall. That is, you could actually look at something and see it. You're not expecting people to hold things in their memory. Consistency, feedback, that is always telling people what the status of the system is and where they are. Clearly marked exits, I should say, enabling people to get out of the application quickly or go back to a home page, shortcuts, etc. Over time, they evolved this a little bit with doing additional research. Nielsen published a second group in 1994. Levi and Conrad published another group in 1996 that was more focused on web evaluation and so on. Here's a group that I use quite a bit, and I thought maybe I would end up describing this in a little bit more detail. I use this because it's a little bit more focused on medical products, which I spend my time doing, but you'll notice that it applies to just about everything. So let's start with the first one, consistency and standards. That is, we should be consistent throughout the user interface, and one way to be consistent is to adhere to standards and conventions in product design. So the standards might be standards for color, layout, where things are located and positioned, the consistent font type and size and capitalization, consistent terminology and language, etc. The second one is visibility of the system state, or the status of the system. So always inform users about what's going on, keep them informed via feedback and displaying information. So it's always helpful for them to know what's the current state of the system, what's the system doing, what can I do during this period of time, where can I go, and what change would I expect to happen after I select something or make an action. That's the notion of visibility of system state. In some ways, you can think about interacting with an interface as kind of a conversation. When you're having a conversation with somebody, it's really nice to know what's on their mind, what they're thinking about, what point they're trying to make, where they're going with their argument. In some ways, this is very similar to a user interface. You want to know, hey, what's the current state of this system? What can I do? Where can I go? And how do I know that I've done things correctly? Another one, pretty critical, is matching the real world. So, you know, we evolved in not medical devices or in electronic systems. We evolved in a natural environment, and as a result, the items that are on our screens probably should mimic that natural environment as much as possible in order to make it intuitive. So the idea here is that just like we think about things in the natural world, that should be reflected in the device itself. The next one here is a minimalist design. Extraneous information that we don't need, information that's just, just decorative, for example, is irrelevant and frankly just detracts people from conducting their tasks. So in this sense, often it's the case, usually it's the case, that less is more. Simple tends to be efficient, and we can usually show people just what they need at a particular time, and then if they need more detail about it, well, they can click on it to see more information. So that's a progressive level of detail. I mentioned briefly minimizing memory load. People have, unfortunately, limited memories. It will talk about their people's capabilities and limitations regarding their memory soon. But basically, if we can have people recognize things instead of being forced to recall them, well, then they're going to do much better with the task. If we can show information instead of having people have to recall it, that's better. If we can provide a hierarchy in our menus and things like that, that's going to provide easier memory. If we can provide smart default values, that's helpful. If we can provide concrete examples, so here's a good example of a concrete example. Things like, you've probably had people or you've been forced to enter your birthday previously on forms. It could say day, day, month, month, year, year, but it would be much better if it said, for example, 10, 20, 99. That way people have a pretty good sense of what they're looking for and don't have to figure out what in the heck does day, day mean, what does month, month mean, and what does year, year mean. Okay. Informative feedback. Give users prompt and informative feedback about their actions. In other words, people should know when they've clicked on something or typed something in that that information has actually been received and is now being evaluated. So you want that information to be specific, not abstract, and so forth. And here's some response time. Again, kind of rules of thumb. They're not specific to be followed exactly, but they give you a pretty good idea of what we're talking about. Give users flexibility of creating customization and shortcuts. That is, provide them with control to kind of customize what it is they want to work on. Provide useful error messages that tell people not only what went wrong, but why it went wrong and what they can do to fix the situation. And make sure that these error messages are polite. Talk to people the way you would want to be talked to. So don't say things like, well, that's a illegal user action, or the job has been aborted, or the system crashed, or a fatal error. People don't talk like that. That's a ridiculous way to talk. But for the longest time, that's exactly what computer systems and other types of technical systems did. And you can imagine that's very off-putting to a user, so talk to them in ways that they would want to be talked to. Specifically say what went wrong, why it was wrong, and what needs to be done to fix it. It's ideal if you prevent errors in the first place. Some ways of doing that are avoiding modes. So what I mean by avoiding modes? Well, have you ever found yourself typing or texting or something and you look down and realize it's all in caps? Well, that's a mode. That is, in one situation, when caps lock is not on, the keys produce one set of characters. When caps lock is on, it produces another capitalized set of characters. But you don't necessarily notice that you've done that. That's a mode. Mode errors are very common, and they're simply when the same sort of action produces two different results when one mode is selected versus another. And it's a very common type of error, so avoid these when possible. Another one is kind of clear closure. Make sure that every task has a beginning and an ending and so forth, and people always know where they are in that task. They know, especially when they've actually completed a task. They're not sitting there looking at the screen wondering, oh, did it take my input or not? Always give them an idea that, request has been received, we've gotten your information, whatever it is that you need to do to tell them that yes, that task has been completed. There's just a couple others. Reversible actions, undo, for example, or multiple undo, going several ways back. Using the user's language. In other words, don't talk to people like a computer. Instead talk to them kind of in the first person and from their perspective. So here's a good example. We've bought 4 tickets for you. Well, that's not ideal. You're better off saying things like, you bought 4 tickets. It gives the user the impression that they're actually in control of this system instead of the system being in control of them. Related to that is you want users to feel in control. Users should be the initiators of the actions. They shouldn't be the responders to the actions. And the way to think about this is these things that you're working on and designing, and frankly that I'm working on and designing, are tools. They are there to serve the user, not the opposite. So tools are incredibly important, but tools are not the main event. The goal that the user is trying to achieve, now that's the main event. The tools just enable them to do that. So as a result, you want users to feel in control as much as possible. And then finally, the help and documentation. People aren't going to read help and documentation ahead of time, or at least very few people would. Instead, it should be provided when it's needed. Context-sensitive help is one way to do that. Okay, so those are some examples of heuristics. But you can see with these heuristics, it's often a top level, something like users are in control. But then there's usually a second level that says, well, here's an explanation of what we mean by that. So let me tell you a little bit about how these heuristics work. Here's a heuristic evaluation table. Imagine you're looking at a product. We did one recently in class for Hyundai. Hyundai was designing an app on people's phones that would enable them to start the car remotely and do all kinds of other things. And we had a number of students go through and identify, do a heuristic evaluation of that, identify what the problems were, how they would go about fixing it, and so forth. So basically what they did is they went through a user interface for Hyundai, and they would find a problem. They would maybe describe the name of the screen. Let's say it's the home page or the home screen. It might provide a screenshot, and they would insert kind of a description of what the problem was that they would find. And then over here, they would indicate what the severity of that description or of that problem was. And then over here, they would indicate the heuristic that was violated. Again, speaking the user's language might be one of the examples that was violated. So what they end up doing then is making a list of all of the problems, the descriptions, the screen they were on, the severity, and the heuristic that was violated. So the way to do this is not to look first at the heuristics, like speak the user's language, and go through and find all the places where that heuristic is violated. Instead, it's to go screen by screen, and for each screen to identify the problems, the severity of the problem, and the heuristic violated. I'll show you an example of that here in a minute. And then speaking of severity, there's kind of 4 levels of severity. 1 would be considered kind of a cosmetic problem, all the way up to 4, which would be considered kind of a usability catastrophe. This is a situation where this has to be fixed before the product can be released. A cosmetic problem would be, yeah, well, only fix this if you have a little extra time. Okay, here's an example I thought I would walk you through of one of my favorite teams. In a previous class, they were looking at a product that was done by Hyundai that Hyundai wanted some feedback on. It was called the My Hyundai application. So I just thought I'd walk you through what some of these were. They used the Nielsen-Norman Group 10 heuristics, which was actually the same one used by Nielsen in 1994. So here they used a different, not very different actually, a pretty similar kind of severity scale, although they added a 0 point that said, I don't agree that this is a usability problem at all. So that's one example, but let me show you an example of what they did. In this particular case, they went through and filled out that form that I showed you before, and then they gathered up all of the things according to the heuristics that were violated, and then they presented them by the heuristics that were violated. So again, they started by going screen by screen and identifying the problems, and then once they did that, they basically sorted according to the heuristic violated and developed this presentation. So here's an example, visibility of system status. Of course, the system should always keep users informed about what's going on, etc. And the issue was that the user's informed of some vehicle status information on the main page, all status information through vehicle state. Basically, they're identifying a problem here. They recommended to research to determine if the current user information provided is enough to supplement users' needs. I think what I want to point out here is one of the things they were able to do is provide specific detail about where the issues were. So you can see they circled it in red and provided an arrow to it. Same thing here, circled it in red and provided an arrow to it to kind of point out what the particular problems were. And then they do that time and time again, and you can go through this at your leisure, but Again, visibility of system status, in this case it was a severity of 1. The wait screen is adding more screens to the design that can be minimized. So basically, remove the screen and add a timer and disable the refresh button. Basically clean this up to be a little bit more minimal. You'll also notice that this is covering two kinds of problems here. Sometimes a particular usability problem will actually kind of account for two heuristics. In this case, it's visibility of system status, but it's also minimalistic design. That is, they're saying, hey, let's remove this screen and add a timer and disable the refresh button. So it's doing two things. It's making it more visible, but it's also making it more minimal. And match between the system and the real world. Again, they're highlighting the areas here and pointing out exactly where they are with a screenshot. So I won't go through all of these, but take a look at when you get a chance. I thought they were really useful, and I thought this particular team did a great job on this. And I'm going to jump down a few screens. This was a pretty long presentation, if I recall. But a pretty useful one. Okay, so that's a heuristic evaluation. Again, the notion is that you've got this set of rules of thumb, things that usually work in a well-designed, usable system. There are things like be consistent, use minimal design, speak the user's language, etc. You have that list in front of you. You go through the product and you identify places in the product where those rules of thumb, those rules have been violated. You jot down what those problems are, you provide a screenshot of it, you indicate the severity, and then later on you figure out how you would go about fixing that. Again, that's useful as kind of a precursor to usability testing. If you do that before you do usability and make those changes, then you're not likely to discover those problems during the usability test. You'll discover them before the usability test, and that makes your usability test a lot cheaper, faster, and easier. Okay, now a second usability inspection method is the cognitive walkthrough, and I'll talk about this just briefly. But the cognitive walkthrough, imagine you were the evaluator. You would evaluate whether a user interface is understandable and easy to learn, kind of cognitive issues, especially for a first-time or one-time user. And then you would, well, we'll start there. That's the main thing. And it really consists of two parts. One, you will write down the steps of a user's task from their perspective. That is, first, click on the home screen. Second, click on File. Third, click on Add Document. Fourth, click on, add title to the document, etc. Those would be the steps. Now that you have those steps, you will walk through each one of those steps yourself. And during each one of those steps, you would ask yourself a set of questions. If I were the user, would I know what to do? Would I know how to do it? So would I know what I'm supposed to do? Would I know how to do it? Would I recognize when it's done correctly versus incorrectly? And when I did that, did the system behave as I expected it would, or did it surprise me? And sometimes just going through that list of things and putting yourself sort of in the user's, it's a bit of role playing, right? Putting yourself in the user's shoes, so to speak, and asking and answering these questions enables you to figure out places where, especially first time or kind of, only sometimes user is going to get confused and have difficulty. And as a result, you know how to go back and redesign the system, or maybe add some instructions, or maybe add some training or something like that that's going to make their life easier. So that's kind of an introduction to first usability evaluation, finding problems and sort of measuring our usability. And in particular, we just focused on this branch first. The analytical branch is what we're doing without real honest-to-goodness users. And next, we'll focus on usability testing, or the empirical branch, the data-oriented branch, where we collect data with real honest-to-goodness users. So that'll be usability testing, and we'll talk about that next.